Well, welcome to our Wired In podcast. This is a chance for us to take a deeper dive into some of the questions that people have been asking. We're here with Bobby Graham still. Bobby, welcome.
How are you?
And we're talking about lighting, specifically follow-up to our conversation about how do I know if I have a lighting opportunity. There were a lot of things that came up during that conversation and people have had questions. We're here with Stephanie, who works in FSG's call center, who fields a lot of these questions, right, Stephanie?
Absolutely.
And also with Brandon Borland, who manages the call center and works with some of the messaging and and these questions come up a lot, right, Brandon?
Oh, that's right. And actually I'm gonna, forgive me, but I'm just gonna correct one thing. We actually don't call it a call center here. We call it a guide center.
That's true.
And one of the reasons why we do that is because we believe that if we can guide people to and through the solutions that they need in their business, that will help them feel more accomplished in their career, run a better facility, just overall make their business better. And sometimes just helping people get a simple answer is all it really takes. And so we call it a guide center. And we get a lot of questions. We get a lot of emails every day from small businesses, from large businesses, from brands that everybody at this table knows and shops and maybe even drinking coffee on the table right now with. And we get all sorts of things. And sometimes the questions are really simple. And sometimes the questions are really complicated. And what I love about what Stephanie and her team are doing is they are trying to find the right SMEs within the company and get those questions answered. And so what I love about this today is we have a chance to actually publish some of what we've learned, right? That's awesome. We get to actually share it.
One of the questions I heard that I really would like to get Bobby to talk about is we didn't talk about doing any kind of testing or piloting program. How does that work, and how do you set that up? Because I know some people asked, like, how do I know if the lighting is going to be better? How do I know what the right solution is before? How do I test things out?
I think guidance, like you talked about, is the number one thing. So we can guide them to the right technology. We can even evaluate exactly what they need and make a decision. But there are field complications. There are things sometimes that just don't fit, don't work right? So I think ultimately testing the product out in a small way to making sure that the decision is right is extremely important, right? As opposed to guiding to the right solution. It is the right solution. We've made the decision, and then we go gangbusters. And for some reason, it works at 10 locations, but the 11th one, it fails miserably because it's not the right size, maybe not the right color. So those are definitely things we love to do.
And, I have a great example of that. And one of the things that we've learned over the years, we had a hotel project that was a retrofit project. And on paper, everything looked right. The part numbers looked right. The product looked right on paper. But then when you actually start to install the product, you find out, hey, wait, this is a high-end facility, is a high-end location. They like it to be really warm. Yeah. They like everything dimmed.
Right.
And when you go in and put LED in there was a challenge presented because when you dim LED, it didn't exactly come out the same way as dimming an incandescent or halogen.
Right.
And so because we missed that step and didn't necessarily work it exactly right in testing it, we had to go back and kind of go back to the drawing board.
Compatibility is a big thing, right? So sometimes we're not retrofitting all the lighting. Maybe it's a part of it, and it's got to coordinate, it's got to communicate together, it's got to dim, right? So they can be very complicated. You've got different manufacturers, different types of lighting all in the same space. So they all have to play nice together. They got to work well together, and that's very, very complicated to understand.
And I know sometimes I've heard people say that, if the lighting system's been installed over a period of time, what's in there may not be what's on the paper that it's supposed to be in there too.
Well, and what was on the original drawing is not always what's installed, right? We have that term in the industry called VE, value engineering, right? So it looked great on a plan set, but when it went to budget and the owner actually bought it, it was much more expensive.
One of the questions that came through was, how do you know if what we're proposing to install is actually going to be compatible with the system that we have?
Yeah, I think it's always a challenge, right? Compatibility is the most important thing. And the only way to understand that is to understand what's there today, and what's going there tomorrow, or what we have in hand. Manufacturers do a great job of specification sheets, putting technology on the paper, and explaining how they coordinate well together. It may sound pretty simple that a LED fixture will be compatible and play nice with a dimmer, but that's not always the case. It could be 0 to 10 volt dimming. It could be line voltage dimming. And if you don't understand that and know how those technologies play nice together, you can make a mistake.
So line voltage dimming is what we've always, it adds resistance. There's a dimmer switch. That's what we've always associated with a dimmer, right?
Right.
And then what is the you said 0 to 10, or what is that?
Yeah, 0 to 10 voltage. Like, think about, line voltage, think about an elevator going up and down. Elevator goes up, lighting goes up, right? Goes down. So LED technology, 0 to 10 volt, is a communication wire.
Okay.
So it's communicating to the fixture or the LED itself, the driver, whatever's in that component, to say, I need you brighter, or I need you less bright. It's essentially talking to the device.
So it's a control wire that's giving it data and then the fixture itself is dimming. The power's not going up and down. The fixture itself is dimming.
Correct. So the fixture is being told to turn on or off by a light switch, or maybe even the communication wire. But then it says turn up to 100% or turn down to 75%. That's the simplest way to understand it.
And that can be wired or wireless, right?
It could be wired or wireless. You for a wireless, you're going to have an additional device typically that'll help communicate. So it's sending a signal to another device. So yes, it could be wireless.
Okay.
So Bobby, in the video, we talked about trusted advisor was a term you used, right? Mm-hmm. So as a trusted advisor, this question of compatibility, where would you start with a customer to determine compatibility? Is it going to be line voltage? Is it going to be 0 to 10? Where do you start?
I think it really starts first with understanding the owner's intent. And what I mean by that is, what is the facility and what are they doing? Compatibility starts with that.
Right.
Because if I don't know how to create an environment to help the employees or to help them sell more product, then I can't help them at all with lighting. So that's first. And then, understanding the next step is providing technology and solution to help them get there as a business first, right? So we can really, really get elaborate with controls and systems and add a lot of great stuff. But if they're not utilizing it and it doesn't work properly, or it's not compatible, it fails, right? It fails them as a system. And so we really need to develop a system that can start with helping them grow their business.
Well, I think, too, we had talked about this earlier, about how you can overcomplicate a lighting system, and it turns into, the guy that needs 4 remote controls to turn on his TV, and no one else can turn on his TV,
right?
Because it's so overcomplicated. So how do you keep from, making sure that we don't overcomplicate the system, or that we don't make it so complex that it doesn't get used?
I always go back to the simplest example that everybody can understand is iPhone, right? An iPhone is extremely complicated. But my son, my 1-year-old son, can use it and watch Netflix. So, but does he utilize it to all its capability? No. Do I? No, not at all. But do I need all of its capability? And I think that's when you think about lighting, there is so much out there. There is so much capability that technology, the lighting technology, can give you and provide for you. But you don't need an iPhone 11 today, right? And if you're not going to utilize,
no, I need one.
I need one too. But if you're gonna, if you're gonna spend thousands of dollars on lighting technology and you don't utilize it for what it's worth, that's not advisable, right? So why not spend the least amount of money possible to provide you a very efficient, effective system, and to help you,
Right.
grow your business, help you manage your business better. And is lighting, that's the most important part about lighting, right? As a business, you want people to walk into your store and feel great, look great, and lighting does that. It helps sell clothes, right? If you look good, if you want to take that outfit home because you look good at the store, and you're going to take it home.
Stephanie, what were some of the other big questions that people ask?
Well, talking about the saving money, we had a couple of people talk about wanting to replace a few light bulbs at a time. They didn't have the money to redo the whole store or the whole warehouse in one particular instance. Do you have any suggestions for that?
I think it's a great idea. I think, certainly everybody has limited resources and limited money to spend. I do, we all do. And we want to spend it the right way, on the right things at the right time. And, unfortunately, a lot of people can't buy all new lighting systems, and they can't have the best technology. So what's the first step? The first step is foundationally, let's maintain what you have. Is it working? Let's get it working. If it's as simple as replacing a few light bulbs, I think that's a great strategy. And that really helps me understand what they have. Because if I can replace a lamp or even a ballast or something like a control device, it allows me kind of into their environment, understanding what they use, how they use it. Is it the right color? Is it the right lamp? And if it's working and it helps them, then let's do it. Let's utilize that. And then the next step to that is really evaluating that. So let's help you kind of understand what you have. Let me understand what you have. Let's get it working. And if it does the job, if it's helping you as a business, or it's helping your employees and your patrons coming to your store, then let's not change it. But then the evaluation of that is it as optimal as it can be? Can you save more money? Meaning, can we replace it with a more efficient product to help reduce the overall cost? And the answer to that is yes, but it may not be today.
Well, and one of the other questions was, how do you evaluate the return on investment? How do I determine if this is the right move?
That's a great question. It's an extremely important question because a lot of businesses make decisions around return on investment. So there are some foundational terms that are in there, right? So you have kW watt rate, right? So kWh rate is what the utility company charges you to utilize energy, right? So that kWh rate could be 6 cents, it could be 18 cents, depending on where you live.
It could be 30 or 40 cents in some areas.
Depending on where you live in the country, it could certainly be very, very high. And so the more your lights are on, the more you're consuming energy. So that's the most important thing, right? So understand what your usage rate is, and with that is your usage, right? So your kWh rate is how much you're using of energy, and what are you getting charged for that? So that's the foundational idea. And then lighting is actually, when it on paper, is pretty simple. Like, you think about 100-watt light bulb. So that's 100 watts, and that's consuming 100 watts of energy, right? And kWh is 1,000 watts, right? So kilowatt is 1,000 watts. Does that make sense? So I think when you understand from a simple standpoint is how much wattage that fixture consumes, the longer it's on, you add hours to that, you're creating cost, right? So once we understand those simple terms, then we can start comparing, right? So today we have a 100-watt light bulb. Tomorrow, if we put in an LED that's 9 watts, we know there's savings. The difference between 100 and 9 is quite a bit. So on paper, we can start to calculate those numbers to create a return. And that, in a simple way, that's what you're doing with lighting.
I just want to point out, I wasn't aware there was going to be math.
I stayed away from math and simplified it, hopefully. But yes, there is a lot of math that goes with it. And there goes also the beware term, right? So I see it all the time in this industry is people calculate savings differently. They add maintenance savings in there. They change hours of operations. So those values can drastically change the return on investment if you're not doing it right. So any company that doesn't share the nuts and bolts of the calculation to help you calculate it yourself is probably not a company I would want to do business with. We're very open book. We provide line item detail. We really get down to the weeds if the customer wants to, because again, that's why we're here. We're all about education, and the more I can educate the customer to make the decision, the better the decision is for everybody.
Well, I think one of the takeaways from that is something you just said is whomever you're working with to evaluate your lights, the evaluation of energy savings for a light is a very simple thing. It's how much energy is being burned, how often are you burning it, and how much does it cost? I mean, that's a pretty simple equation. And if you're working with someone and that ends up being very complex and there's all of these other things being added in there, you might not trust those numbers as much. Is that what you're saying?
Yeah, I absolutely would. And, it becomes more complicated when you add more than just one lamp. Right. And more systems and controls. So it can be very complex, very complicated to understand. But at the end of the day, it is really simple, and we can put it down on a sheet of paper and figure it out.
And I think one of the things that, and I think one of the points of sitting down around a table like this, and then of course also in the wired in video, I think one of the points of these pieces of material is to help kind of cut through some of the noise, because there tends to be a lot of companies out there. There's a lot of companies out there that can do LED. There's a lot of companies out there that can do just lighting maintenance to maintain the current systems and stuff like that. And there's a lot of good ones out there. But there's also some out there that just come selling a product, or they just come, selling, hey, LED is more efficient, and that's where they stop, right? And a great example, personally, I dealt with a project where I had a church, so a facility that's not run a large number of hours per week, looking at LED. They had a company that was selling a product to them. And so the company is saying, well, it's efficiency and it's lumen output and all this, or all these things, you're going to save money. There was no calculation involved with how many hours it was actually running and what the building was actually doing and what was currently in there and all that. And so there was a lot of emotion going on at the table because the facility manager was tired of renting lifts to change these fixtures up top. He's tired of seeing the lights burn out. He thinks LED is going to run forever. He doesn't have to rent a lift, every couple of months and that sort of thing. Not realizing that the true cost was going to be massive compared to renting the lift every quarter and just changing the existing technology. And, from a traditional, I work for a company that sells lighting. I'd love to sell them lighting. But we had to sit there and we had to go, you know what? It doesn't make sense here. The numbers don't make sense.
Because of how much the lights were on?
Because of how much they weren't on.
Oh, okay.
They weren't on most of the week, and so it didn't make sense.
There was no return on investment.
No return on investment. But as a trusted advisor, we sat and we looked at the real estate envelope as a whole, and we said, well, look, HVAC costs, some other things, it just doesn't all add up to doing this retrofit here. But in this one portion of the building where you're running 40 hours a week and you've got X number of fixtures,
like in a preschool, or
it makes sense.
Yeah.
Let's start there. Let's see if that meets your goals, and then let's go from there.
Yep.
You were throwing out too. Both of you just kind of said something. There's a lot of people out there that make a lot of money out of confusing customers. And there's some salesmanship that goes on with lighting, and it's better, it's this, it's going to do this, it's going to do that. What are some of the terms? And there's a lot of terms that people throw out. I know we've heard like CRI, we've heard efficacy, we've heard there's a lot of terms that people throw out that may be confusing, that I don't think are that confusing in terms. Could you talk about some of what those things are?
Yes. Yeah. So CRI is color rendering index, and it's based on the sun. So the Kelvin temperature is another term. Kelvin temperature is the color, and that's the black body, right? So you heat up an element, piece of metal, the hotter it gets, it changes colors, gets more to like a blue, right? But as it's warm, like a kindling of a fire, it gets more towards the yellow.
Which is always confusing for me coming from a design standpoint, because the the higher the temperature, the cooler the light.
The higher
and
the
lower
temperature.
the temperature, the warmer the light. That one was always really confusing to me.
And a lot of people flip-flop the CRI and Kelvin temperature, so they're not the same, right?
They're not.
So when we talk about its color rendering indexes, if you put a red T-shirt in under sunlight, it's going to look like a true red. You put it inside under a fluorescent light, it looks different. And it's kind of neat. Like we've got a booth that we put different color rendering indexes under, like lamps, and you can see blues look different under different CRI color rendering indexes. And then color plays a role too, right? So if it's more of a bluer light, then it's going to look, a blue T-shirt's going to look more blue. But those are two conflicting terms, right? Two different terms, but everybody confuses those.
Well, because lighting companies can fake white light by not necessarily providing as much red or blue or green in that white light. So it affects colors differently, right?
Yeah, that would be color spectrum. Yeah,
Okay.
so those are different. So you think a good way to think about that is like an LED chip. An LED chip is actually it can be blue, it can be red, but it's, you think of the red, blue, green, like
Right.
the rainbow. They can be blended like RGB, but a lot of times there's a phosphorus coating over the top of the LED chip, which gives it its white color. And what it's doing is it's pulling the blue out of the light distribution. So if you
Okay.
think about a blue flashlight and you cover it with an orange piece of film, it's going to reduce the amount of blue that goes through, right? Or it's going to project more of an orange type color. Does that make sense? So that's pretty neat, but LEDs are that way. They put kind of a phosphorus coating over the top of it to get the color you need. And then you look at the RGB is where it's color. The color changes. Like, so you could turn a flashlight from red to blue to green to orange, and those typically have a lot of different LED chips in there, but they're standard color, and they're blending the
Right.
LEDs together to make the color you want. So it's pretty neat.
So what about efficacy? What is that?
Efficacy is a kind of a cool term. A lot of people say, well, efficiency. I say efficacy, and it's really the proper way to say it, and it's lumens per watt. So the greater efficacy the lighting fixture has, the more light it's able to produce with the least amount of wattage.
So is it kind of like miles per gallon, or is it that kind of a rating?
Yeah, it's a good way to think about it. Like, so let's go back to the 100-watt light bulb, right? So a 100-watt light bulb has a filament in there, and if you think about the old-timey light bulbs, the filament, they're not that bright, right? So, but they're consuming a lot of energy, right? It's 100 watts. So LED, now you can produce the same amount of light with probably like a 6-watt LED or even less now. And so you think about 6 watts producing the same that it takes to produce an old 100-watt light bulb. That's pretty significant. So an LED is actually, the lumens per watt is going to continue to grow. It grows every year. We're reaching somewhere close to 200 lumens per watt on some product. The average is around 121 lumens per watt. But I mean, you think about that, an old incandescent was much, much less. So that's the efficacy term, and that's what we're going to see. Really, technology, as it gets better, product gets smaller and consume a lot less energy.
So you had to have one more, and you just talked about it. What is the difference between lumens and foot candles?
So always a good question too, and those are the, like CRI and color rendering index, a lot of people flip-flop. So lumens is how much light is being pushed out of the luminaire or the fixture.
Okay.
So if you think about looking at a candle, right, I can see that candle. That's the light you're seeing. That's the lumens. So coming out of the fixture, that's what you're seeing. Foot candle is basically it's a reading, it's a measurement. It's so if I'm 1 foot away from a candle, that's 1 foot candle.
Okay.
But what it's doing is it's measuring the amount of light. So you think about a fixture over your head, and I have a light meter sitting on the table in front of me. The amount of light that's being produced out of that fixture, and it is measured, and it's measured in the terms of foot candle. And that's based on, so those are two other terms, right?
Okay. We had so much to talk about that we are going to break this up into 2 parts. So we're going to end part 1 right here. If you want to hear the whole conversation, you can look in the show notes and go to our podcast and subscribe to that, where you will see the entire conversation now. If you want to hear the second part on YouTube, don't forget to like, subscribe, and ring the bell, and you will be notified when we post part 2 in just a few days. Thank you so much, Bobby, for your time, and for everyone for having a great conversation about lighting. I know there's a lot more topics that people have questions about, and I know there are a lot of more questions people have, but if you need to get answers to those, you can always send us an email at questions@wiredin.tv, or you can ask in the comments section of the YouTube. And if someone wants to find out more information about FSG, Brandon, how could they find out more about FSG?
Go to www.fsgi.com. You can give us a phone call. You can fill out a form, send us an email. You can even live chat with us if you'd like. And we'll be happy to answer your questions.
Excellent. Thanks, guys.